Hi there, it's Mr. Logue and this is another maths lesson on reading line graphs. Let's go through some top tips for this lesson. Top tip 1, get your ruler ready, or at least something with a straight edge because you'll need it to draw lines from your x and y axes to the exact line. Top tip 2, if the graph has 2 lines, make sure you are reading the correct one according to the question you're answering. Top tip 3, if the line is halfway between intervals, work out what number is either side of those interval numbers. For instance, on this line graph, we have intervals going up in multiples of 5. Halfway between 15 and 20 would be 17.5. And final top tip, check the scale of the axis. As I've just said, on the y-axis on that graph we're looking at, it's going up in 5s. Here's the first question. This graph shows wages paid to teenagers by a fast food restaurant. A. Carl worked 4 hours. What wage was he paid? B. Kelly worked for 4.5 hours. What wage was she paid? C. Kareem worked for 7 hours. What wage was he paid? D. Kesha was paid £21. How many hours did she work? If you'd like to solve these yourself, pause the video now. You can unpause and check the answers as we go through them. Right, so let's have a look at A. Carl worked for 4 hours. What wage was he paid? Looking at the graph along the y-axis, or sorry, up the y-axis, that's the wage paid, going up in intervals of £2. And along the x-axis at the bottom, there's the hours worked. And if we look, we can see that actually midway between each of these boxes on the graph, that's 1 hour. Midway between, that's 1.5 hours too. So let's go along to where we see 4, get our rulers ready and draw a nice line up to there. And then from the line, where it meets the line of the line graph, we're going to draw along to the y-axis. You can see there, it's £24. So for 4 hours work, Carl was paid £24. On to B. Kelly worked for 4.5 hours. What wage was she paid? About just a moment ago, midway between 4 and 5, we have a nice line there. That's 4.5 hours. Let's draw up our ruler until we meet the line of the line graph. And then from there, we're going to draw along, and as we can see, it's halfway between 26 and 28. Halfway between 26 and 28 is 27. Kelly was paid £27. C. Kareem worked for 7 hours. What wage was he paid? Our ruler ready again. Find 7 hours along the x-axis. Draw a line up with our ruler till it meets the line of the line graph. And then from there, we're going to draw a line across. And we can see it meets over on the y-axis 42. Kareem was paid £42 for his 7 hours. Right, Kesha was paid £21. How many hours did she work for? Right, so this is the opposite way round. We're being given the amount she was paid. We need to know how many hours. So we're going to start on the y-axis. We're going to find 21. We don't have 21 marked, but we have 20 and 22. So midway between, we're going to draw a line across where it meets the line of the line graph. And then from there, we're going to draw down, straight down there, and it comes halfway between 3 hours and 4 hours. So that must mean that Kesha worked 3.5 hours. Here's another line graph. This graph shows the number of toy cars a machine produces during a period of 10 minutes. A. How many toy cars does the machine produce in 1 minute? B. How many toy cars does the machine produce in 5 minutes? C. How long does the machine take to produce 21 toy cars? D. How long will the machine take to produce 36 toy cars? Pause now if you'd like to solve yourself. We'll start off together looking at A. How many toy cars does the machine produce in 1 minute? So by now we should be getting used to looking at our x and y axis. We can see that along the bottom are the minutes, and along the y axis going up are the number cars in 1 minute. Let's find one, draw our line up, we meet there, and then draw our line across from that line, and we can see it meets up. 1 minute, 3 toy cars are produced. Now let's look at B. How many toy cars does the machine produce in 5 minutes? Find 5 along the x-axis. Get your ruler, draw up to the line of the line graph, and then use the ruler to draw a line along to the line of the y-axis. 15. So 15 toy cars are produced in 5 minutes. C. How long does the machine take to produce 21 toy cars? So this is the opposite way round. So let's use our y-axis where we can see the number of cars produced. Find 21. Get the ruler ready to draw a line across to the line of the line graph, and then draw down to the x-axis. 7. So 7 minutes to produce 21 toy cars. D. How long will the machine take to produce 36 toy cars? So we have 36 at the top of the line graph. Doesn't meet the line of the line graph yet. It would if the minutes were going on a little bit further. And we could work out, based on the intervals that those minutes are going up in, how many minutes it would be. But we can also work out based on the rate of production of cars. We know that in 1 minute, 3 cars are produced. From the line graph, in 2 minutes, 6 cars are produced. And in 3 minutes, 9 cars are produced. So for every minute that passes, 3 cars are produced. So the rate of production is 3 cars per minute. That means that 36 cars divided by the 3 cars will give us how many minutes? 36 divided by 3 is 12. That means that it will take 12 minutes to produce those 36 cars. One final graph. This time we have 2 lines. It shows the different wages paid by a retail shop to its employees on weekdays and at weekends. A. How much does an employee get for working 4 hours on a weekday? B. How much does an employee get for working 6 hours at a weekend? C. An employee works 4.5 hours on Friday and 5 hours on Saturday. How much is he paid? Employee works 5.5 hours on both Wednesday and Saturday. How much more did she receive for working on Saturday than on Wednesday? Pause the video now if you'd like to go it alone. We'll start with question A. How much does an employee get for working 4 hours on a weekday? Well, weekdays are Monday, Tuesday, Wednesday, Thursday and Friday. So let's go up to the weekday line from 4 hours. And then draw a line across. And we can see that for 4 hours work on a weekday, £40. B. How much does an employee get for working 6 hours at a weekend being Saturday and Sunday? Let's draw the line up from 6 hours up to the line of the weekend pay, and then across to the y-axis, and it meets 120. £120. C. An employee works 4.5 hours on Friday and 5 hours on Saturday. How much is he paid? Well, Friday will be the weekday rate and Saturday will be the weekend rate. So let's start with the 4.5 hours on Friday. 4.5, well, 4.5 will be halfway between 4 and 5. So let's draw a line up from there to the weekday line, and then across, and it's halfway between £40 and £50. Halfway between £40 and £50 is £45. Let's do the same with the 5 hour for Saturday. Saturday is a weekend, so we need the weekend line. Let's draw up to the weekend line from £5 and then across. We can see it meets 100. £100 for Saturday. How much is he paid in total? £100 plus £45 is £145. An employee works 5.5 hours on Wednesday and Saturday. How much more did she receive for working on Saturday than on Wednesday? Let's find 5.5 hours along the x-axis. 5 and 6, so it must be halfway between. Let's first draw the line up to the weekday rate for the Wednesday and draw a line across from where it meets the line of weekday, midway between 50 and 60, 55. Drawing from the same place because it's the same amount of hours, but up to the weekend line now. And then we can draw across from there. Wages show £110. So on a Saturday, for 5.5 hours, £110. How much more did she receive for working the Saturday? Well, that will be £110, subtract £55 to find the difference. 110 subtract £55 is £55. In your last line graph lesson, I suggested that you take a walk, a timed walk, and at different intervals, maybe of 5 minutes throughout the walk, work out the distance you've travelled. What I'd like you to do for a next step is to go on the same walk and time it again and see the difference in time it takes you. And then use those two separate pieces of data to create a line graph that's got two different lines. So one marking your first walk and one marking your second walk. Hopefully you'll be slightly different in time. Maybe you'll be slightly faster, maybe you'll be slightly slower, depending on the weather, how much energy you've got. Maybe you walk slightly faster the second time. Right, hopefully you enjoy drawing the line graph, and that's the lesson on reading line graphs. Bye for now.